Okay, chemistry students, this is Miss Kirkman back to help y'all work these specific heat problems. And so I have two examples that I'm going to work for you. Here's the first one, and then we'll do the second one. I'm going to go through step by step. If you follow these steps, every single time you should be able to solve for any specific heat problem. So our first example says the temperature of a piece of copper with a mass of 95.4 grams changes from 25 degrees Celsius to 48 degrees Celsius. When the metal absorbs 849 joules of heat energy, what is the specific heat of copper? Every time I ever start a problem, I do two things. I write down what I'm given and what I'm looking for. And so we have a lot of different givens. First of all, we need to remember we have this equation where it's Q equals MC delta T. Q is our heat, M is our mass, C is our specific heat, and delta T is our change in temperature. To calculate delta T, I take my final temperature minus my initial temperature. So our givens, everything that we are given, we're going to go ahead and record these. So for my givens, which I just do a G for given, I'm going to look and it tells me a temperature of a piece of copper, mass of, and so I have a mass of 95.4 grams. So I know that M stands for mass is 95.4 grams. I'm going to keep going. I know that the temperature changes from 25 to 48. In the previous video you watched, the lady tells you that the from and to are key words. From is your initial value and to is your final value. So then that means I know this delta T here. So I know T initial is 25. And I know that T final is 48. Then I'm going to keep going. I know when the metal absorbs 849. So I'm absorbing, which that tells me it's an endothermic reaction. Energy is being absorbed. And then I know that it's 849, so that's my Q. So I know Q equals 849 joules. So now I just need to plug all of this in. I'm going to plug in all these values into these equations, and we're going to solve mathematically. As long as you are decent on your algebra skills, it's a quick plug and check. If you're not decent on your algebra skills, remember things that undo each other. Division undoes multiplication, subtraction undoes addition, and those should be the ones that you need to know here. Division undoes multiplication, and vice versa. So, plugging in. So for my Q, I'm going to plug in my Q. So over here, I'm going to have 849 joules is equal to, and then now next comes my mass. I know my mass, I will plug that in. I'm going to put parentheses around it so I know whenever one number ends and the next one begins. And so this is 95.4 grams in those parentheses because that's the end of mass. The next one coming up is C. Guess what? C is specific heat, and C is what I'm solving for. So I'm just going to leave C as is. That's what I'm going to end up solving. And then I know delta T. First I need to plug into delta T to figure it out. So a little side note over here, that this is going to be equal to 48 minus 25. I plugged in my T final minus T initial, so that's 48 minus 25, and that's going to equal 23. And so then for this last part, delta T is 23 degrees Celsius. So then now I'm just taking my calculator and I'm plugging in. This C is over here. I want to get it by itself to solve for it. It's being multiplied by this number and this number. Remember, I said how you undo multiplication is division. Whatever you do to one side, you have to do to the other. So on both sides, my second step is going to be to divide by 95.4 and to divide by 23. So whatever I do to one side, I do to the other. So I'm dividing by 95.4 and 23. So these cancel, it leaves me C all by itself. And whenever I take my calculator and I plug in, I take 849 and I divide it by 23. And then I hit enter and then I click divide again, and I'm going to divide that number now by 95.4. and I get 0.386929. Remember to round for sig figs. If you don't know what sig figs are, that's okay. In this case, I have 3 sig figs. I left off when copying the problem, but I should have 3 sig figs. I didn't do my 0.0, 3 sig figs. And so therefore my answer should have 3 sig figs. So I'm gonna say that C is equal to 0.387, and that's going to be joules per gram degrees Celsius. So, real fast, right there, so you can see the whole problem, and here's all of our work. Okay, so that's how you work these problems, algebra and wonderful math. Plug it in, chug in. So our second example is right here. And we have, the problem says, using the same copper, so we have another copper solution, another piece of copper with a mass of 75 grams is heated until its temperature increases from 2 degrees to 150. How much heat energy is released or absorbed? So now we're solving for Q, we're solving for energy. We know the specific heat, it's from the previous problem. So if I carry that over, that's one of my givens, I know it's 0.387 joules per gram degrees Celsius. We just solved for that, that's our previous answer. Because we're talking about copper still, and so copper is gonna have the same specific heat. If we solved it in the first problem, we now know the specific heat. Other givens I've underlined, we know our mass. It is 75 degrees, I said that twice, 75 grams. And then our temperature, we're gonna take our delta T is gonna be T final minus T initial. So T final minus T initial. So I'm gonna take 150 minus 2, and that's gonna give me 148. So now I'm plugging into my formula, Q equals MC delta T. I don't know Q this time, that's what I'm solving for. I know M, it's 75. Again, I'm gonna put it in parentheses. I know C, 0.387. And I know delta T, it's gonna be 148. So now it's just a plug and chug, you're multiplying. A couple of things here. It's asking you how much energy is released or absorbed. Our final minus initial, first of all, we're heating it. It's gonna be absorbed. I also know this because I'm gonna get a positive Q value for this. So when I take these numbers and I take 75 times 0.387 and then I hit enter, and then I'm gonna do times 148. And that equals 4,295.7. So Q, and I want 3 sig figs, is 4,296 joules. My units are joules. So now then, this is a positive number, which means it's endothermic, which means heat is absorbed. So hopefully seeing 2 problems worked helps you out. I'm gonna go ahead and do these a little bit up more close so you can see the work. So just simple algebra. Most of the time you're just multiplying or dividing. If it makes you solve for a T final or a T initial, then that would be the one time it gets a little bit more complicated. If you have questions, feel free to reach out to me or any of whoever your chemistry teacher is. I hope you all are staying safe and good luck.